Today, I would like to present our project called Reloop. So this is our introduction. So our project Reloop is an intelligent, eco-friendly recycling device that allows communities and small businesses to transform all types of plastics into 3D printing filaments that are perfect for the prototyping purpose. This is the industrial extrusion line workflow that we are trying to imitate. So our project will follow the same principle like this. This is the problem statement that Malaysia generates large amounts of plastic waste, and current small-scale recycling machines are bulky and expensive, so we require for a smart and portable innovation. This is our project goals. Our project goals are to create a smart, efficient, eco-friendly, and automated system. So we will reduce plastic waste, save energy, and minimize manual work while ensuring consistent filament quality. This is the workflow and process.
Shredding and drying. Make sure bottles, caps, or containers are clean and dry before shredding, such as remove labels, glue, dirt, and other contaminants. Step 2. Extrusions. Fill the hopper with plastic strap and ensure the screw fit plastic strap consistently into the extruder to ensure consistent diameter of produced filament. Step 3. Cooling. Cool the filament slowly and evenly. Two fans will be placed near the die to cool the newly produced filament slowly so that it can be pulled into the correct width in the next step.
Step 4, which is pulling. It is placed right after the cooling stage, so it will stretch the filament slightly when it is still warm enough. So we apply a stepper motor here to control the RPM of roller, and also the roller has a texture space to grip on the 3D filament. Then for the step 5, which is sensing. This is the place where the data is sent to a microcontroller so that it can adjust the speed of stepper motor rotation. And for the final step, which is spooling, it used to wind the 3D filament onto a spool for use in 3D printing. It is assisted with filament guide with ART ME3D to allow the filament to be spooled neatly. So we also apply a stepper motor here to control both the filament guide and also the rotation of spool.
So I'll be explaining how we could implement AI and PID controller in our 3D printing filament upcycle machine. Alright, so this is the software infrastructure for stage 1, which is for the PID controller. So the data for the filament diameter, extrusion speed and temperature, the humidity and environment temperature, and also the RPM of the motor will be input into the PID controller. And the PID controller will adjust the speed of the motor based on the inputted motor RPM and also the filament diameter. And all of this data will be stored into a database called Superbase for the training of the neural network. So this is stage 2, which is the training of the neural network. So we will use TensorFlow and also the data we store in the Superbase to train for the neural network. And the neural network will be input into the control system in order to control the RPM of the motor. So these are the brief codings for the PID controller. And the total estimated cost for our projects is 1,980 ringgit and 71 cents. So these are the improvement and feature enhancements that could be made. One of it is using a laser sensor for higher accuracy. Next is higher accuracy stepper motor, cooling water bath to replace the fans for even cooling, and using a larger spool so we could spool more 3D filaments at once. So these are the safety and ethical consideration. One of it is high heating elements during plastic melting that may cause burn on our skins. So we could use thermal insulation materials on our skins, or maybe using a warning sign to increase the alertness. The next is entanglement hazard when shredding. So we could implement an emergency stop button to reduce further damage. And the last one is electric shock. We could prevent it by using proper grounding and fuse protection.
This is a simplified version of our project, and due to budget constraints, this is a very simplified version. And so let's look at the first part. This is the shredding unit. So basically, recycled plastic will enter this shredding unit, and the shredder over here will turn using two motors, and shredded plastic will be produced below. And so it's collected using a container, and then the container will be put into a furnace for drying purposes due to some chemical properties. And then the dried shredded plastic will enter the hopper, and this hopper will collect all the plastic, and then it will enter the extruding unit. So inside this extruding unit, there's extrusion screw which pushes the molten plastic. So outside here, there will be heating elements that will heat up the plastic to 300 degrees in order to melt them. And then it will be compressed, and it will come out from this hole, and at the end, we will get a nice 3D filament. But the problem here is that the 3D filament diameter is not accurate at all. And so we need a pulling unit in front in order to control the diameter of our 3D filament. Controlling the speed will control the diameter. And so in order to control it accurately, you will need a filament sensor. So this filament diameter sensor uses a Hall sensor, and you provide a feedback to the Arduino. So the Arduino will collect the data, and then using a PID algorithm will control the stepper motor of the pulling unit. And so after this part comes to the last part, where we have to spool the filament onto the spooler. So this spooler consists of the spool itself, the filament guidance, and the stepper motor over here. So the stepper motor will be turning this wood over here, this joint. And so when it turns, there's a GT2 pulley belt which connects to this part and this part. And so when it turns, these two parts will also turn together. And so the filament guidance is controlled by another mechanism which uses a lot of gears, and when it turns, this wood at the back will move forward and backward, right? As you can see here, this one will move forward and backward, but it's very simplified, so you can't see it. And then there's a bearing in front which will move in the horizontal axis, also forward and backward, in order to align all the filament onto the spool correctly, so that it won't be messy. Alright, and so the outcome of our project is a nice 3D filament which can be used for other projects. That's all. Thank you very much.